Section 6.4, the law of sines. We already know how to use trig to solve right triangles, but now we're going to look at how to do oblique triangles, triangles that are not right. So first, let's just talk back when you took geometry. You learned about side, angle, 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 side, side, all that sort of stuff. You hopefully are thinking right now, remembering about side, angle, and that there's some things that you need to remember with it because it doesn't always work. So hopefully you've already seen that, but briefly I'll go over a little bit. So to talk about side, angle, the best thing to do is just look at all the different possibilities. When we have an angle and the side B, and then we're looking at the next side, so we have side, angle. One thing that could happen is that maybe that side isn't long enough to even reach down to complete the triangle, so that would not be a triangle. It could be just long enough so that it just barely touches. In that case, that would be a right triangle. Back in geometry, I think you learned that as hypotenuse leg, but that's not important for this class. You could also have that A is a little bit longer than that, in which case it would intersect our angle at two different places. So that doesn't really help us because we could get two different triangles. But then there's also this other case where A is longer than B, so it can only touch out here. It won't be another triangle on the inside because it's too long to touch. So anyway, the point in reviewing all of those is if we have a triangle and we're given an angle side and an angle, or a side angle or side angle, you can solve the triangle using the law of sines. So all that it says is you can take sine of an angle over the opposite side, and all of those ratios are equal. They're proportional. Sine over the side equals sine over the side equals sine over the side. So let's do a couple examples. So there's a satellite orbiting the Earth. It passes over Phoenix and Los Angeles, which are 340 miles apart. At one instant, the satellite is between the two stations, and the angle of elevation is measured from each to be 60 degrees and 75 degrees. How far is the satellite from Los Angeles? So we know two angles, and we know the distance in between. So we have angle, side, angle, like is listed up here, which means we can use the law of sines. So we can set up our proportion to be sine of 75 over A equals sine of 60 over B. If this is 75 and that's 60, that means the other angle would have to be 45 degrees. 45 plus 75 plus 60 is 180. So we can set that equal to the sine of 45 over C, but C is 340. So I wrote this as an extended equation, but what that means is we can take the one that has the numbers and set it equal to either of the other two to solve. Since we're trying to find how far it is from Los Angeles, we're trying to find B. That's all that we care about. So we're going to ignore that first part altogether. And then sine of 45, that would be your middle finger for our left-hand trick. So that would be square root of 2 over 2, square root of 2 over 2. So sine of 45 is square root of 2 over 2 over 340. We can simplify that to be just the square root of 2 over 2 times 340, 680, equals sine of 60 over b. 60 would relate to our pointer finger, so fold that down. And sine is the second number, so that'd be square root of 3 over 2 over b, or you could just say square root of 3 over 2b. And then cross multiply. (680) square root of 3 equals 2 square root of 2 times b. So divide by 2 square root of 2. Let's first get rid of the square root on the bottom, so multiply by square root of 2 on top and bottom. So on bottom now we just get 2 times 2 is 4. And this becomes 680 square root of 6. (680) divided by 4 is 170. So b is 170 square root of 6. Which is about 416.4 miles. So here's another example. It says solve the triangle, so that means we need to find any missing sides and angles. So let's set it up. First, we can find the angle pretty easily. 20 and 25 is 45, so that means this angle must be 135 degrees. Then we can set up our proportions using the law of sines. Sine of 20 over a equals sine of 135 over b. Equals sine of 25 over 80.4. So let's go ahead and solve for a first. So we have sine of 20 times a when we cross multiply. Sine 25 times a equals 80.4 times the sine of 20. So divide both sides by sine 25. 20 and 25, those weren't important numbers. We never memorized those. Those weren't on the unit circle. So let's just type it in. 80.4 times, make sure you're in degrees, times the sine of 20 divided by sine of 25. So a is 65. We'll round up and say 65.1. Now let's do the same thing over here, but solve for b. So we have sine of 25 times b equals 80.4 times the sine of 135. 135 is just 45 degrees more than 90, or 45 less than 180, however you want to think about it. So our reference angle will be 45 degrees, which means that sine is square root 2 over 2. And since that's in quadrant 2, sine is positive, because all students take calculus, sine is positive. So we have 80.4 times the square root of 2 over 2 equals sine of 25 times b, divided by the sine of 25. When it comes to putting in your calculator, you can just type sine of 135, that's fine as well. So 80.4 times sine of 135 divided by sine 25. So b is 134.5. Now these next three examples are all related to the side-to-side angle. This first one is the one solution case. We'll talk about that as we're going through. So we're also not given the triangle here, so we need to draw it. So we have a 45-degree angle, a length of 7, and a length of 7 squared root of 2, so that's going to be almost 1.5 times long as the other. So we have the 45-degree angle. At A, and then the side across from that is 7 square root of 2. And if I call this B, then this side over here is 7. That would be C, and we don't know how much that one is. We can set up our ratios though. Sine of 45 over 7 square root of 2 equals sine of B over 7 equals sine of C over C. Now we don't know either bit of information over here, but that's okay, because once we find B, we can subtract from 180 to find out what C is. So let's start by finding B. 7 times sine of 45. Sine of 45 degrees is your middle finger, so that's square root of 2 over 2. Equals sine of B times 7 square root of 2, so without doing anything, 7 square root of 2 over 7 square root of 2 is going to cancel, so we're left with just 1/2. And we can ask ourselves, when is sine 1/2? So if you work it backwards using the left-hand trick, that would be when your ring finger is down. Then sine is 1/2. And the degree of that would be 30 degrees. So when B equals 30 degrees, could also perhaps be anytime the reference angle is 30 degrees, but we are looking for a positive value. Obviously can't be more than 180 because it's part of a triangle. So it could also be the reference angle could be 30, which would mean an angle of 180 minus 30 so 150. But since we know an angle is 45, that would be too many degrees in the triangle, so it also can't be 150 degrees. So it's only 30 degrees. That's the only solution. There's only one solution. So if B is 30, A is 45 degrees, so together that's 75. So that means angle C has to be 105 degrees. So then we can solve that using our first ratio with it. So sine of 45 over 7 square root of 2 equals sine of 105 over C. Sine of 45, we said before, is square root of 2 over 2 times C. Equals 7 square root of 2 times the sine of C, which is, C is 105, so that's just a number. And we're going to divide by square root of 2 over 2. So when we divide by the square root of 2, that's going to cancel. But dividing by 1/2 is like multiplying, so this is really like 14 sine 105. (14 times sine of 105 is 13.5. So we found our missing angle, both angles, and the side 13.5. So again, we're not given the triangle. You can draw it out if you want. You don't really have to, because you just need to know that angle goes with the matching letter. So we have sine of 43.1 over 186.2 equals sine of b over little b, 248.6, equals sine of c over c, which we don't know. So there's our three missing pieces of information. Let's first find how much b is by cross multiplying. So that's 248.6 times the sine of 43.1 equals sine of b times 186.2. So let's divide by 186.2. Divided by 186.2. So we just get 0.91225 equals sine of b. So to find out what b is, then we have to do the inverse sine, which is the second function of the sine button. And you can do second to get answer to input that fraction for you, the decimal for you. So b is 65.82 degrees, or just 65.8. If we add that to the 43.1, it's 108.9. Subtract it from 180 to find out our third angle. So C is then 71.1 degrees. And then we can use that to find the length for side length of C. Now, one of the things you need to remember with this is whenever you're doing sine and get one of these values, all that has to be is the reference angle, which means it could also be 180 minus that. So let's see if that would work. If we did 180 minus 65.8, that would be 114.2. If that was 114.2 and the 43.1, there's still an angle left over for angle C. Subtract it from 180. 22.7 degrees. So this is where we said two solutions. Here's solution 1 or solution 2. It could either be 65.8 degrees for angle B, or 65.8 could be the reference angle. So it'll be 180 minus that to get our other possible case. So that means we have two portions over here to solve this other proportion with. So let's first go with solution 1. Sine of 71.1 over C equals sine of 43.1 over 186.2. And I'll set up the other one as well. We could have sine of 43.1 over 186.2 equals our other angle C, sine of 22.7 over C. So when you cross multiply, we'll solve the one over here in red first. 186.2 times sine of 71.1 divided by sine of 43.1. C could be 257.8. I'll put that up here with solution 1. Or if you solve solution 2, our green proportion, 186.2 times sine of 22.7 divided by sine 43.1. C could also be 105.2. So basically you just need to check and see if if you used our solution as a reference angle, if it would still work to form a triangle, if the angles would be less than 180. And here's our last example. A is 42, angle A is 42, A is 70, and B is 122. So if we set that up, sine 42 over 70 equals sine of B over 122. Cross multiply and solve. So we have 122 sine of 42 over 70 equals sine of B. We get 1.166 equals sine of b. And we know that sine is never more than 1, so there's no solution. Sine is always between 1 and negative 1.